quicker? All right, sine of theta is square root of 2 over 2. So I'm going to set up my triangle. Here's my theta opposite over hypotenuse. So square root of 2 squared plus b squared this time is c squared. And we'll be doing a lot of this today where we find a missing side. So I get 2 plus b squared is 4. So that means b squared is 2, which means this side is also the square root of 2. So sine of theta, of course, I already have is the square root of 2 over 2. Cosine of theta is also the square root of 2 over 2. And the tangent of theta is the square root of 2 over the square root of 2, which is just 1. Then if I start flipping them around, that's whenever I get into a little bit of work here. 2 over root 2, so I root 2 and root 2 it. I get 2 root 2 over 2, which is square root 2. Secant, I don't even have to do all that work again because they're exactly the same value, so it's square root of 2. And what happens if you flip 1 over? It's just 1. This is a unit circle value. Yeah. Yes. 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 All right, so today is solving right triangles. Not special yet. Special right triangle. What? This should have been. You should have learned this in geometry. All right. So what we're getting ready to do is what we call solving a right triangle. And solving a right triangle means that you find every side and every angle within that triangle. So you have to remember things like how many degrees are in a triangle. 180, right? And Pythagorean theorem to find missing sides, which we've been doing. But there are some special right triangles because for all of those, I have to have at least 2 sides or I have to be given at least an angle, right? But there are some special triangles that you don't necessarily have to have that much information for. And those, yes, that's right, are 45, 45, 90, which these describe angles, by the way. 45, 45, 90 triangle and a 30, 60, 90 triangle. Now, what does this mean? This means that these angles are both 45 degrees. And if you rewind back to geometry, you will remember that if the base angles are the same, what do you know about the legs? They're the same also. So I know that if these 2 angles are the same, then these 2 legs are the same, or vice versa. If I know the legs are the same, I know those base angles are the same. Okay? Y'all tracking with me? Whatever this value is, we will call it, I hate to call it X, but I'll call it X. This value has to also be X, right? If you went through and did the Pythagorean theorem, you would find that this is always the square root of 2 times X. Now, that's very, very basic. If I told you that this was 45 degrees and that this was 7, you could tell me what everything else in that triangle was just from those 2 things. Because this angle has to be what? 45, because I've used 90. This is 45. That only leaves me 45 here. And if both of these are 45, then this leg has to also be 7, which means that this hypotenuse, 7 times the square root of 2. So that's the pattern. Now, will it always look exactly like that? No. It doesn't matter, just because you could write this as X times the square root of 2, either way. Now, that's the easy way to look at it. What if I'll even flip it around. Mm-hmm. That's exactly right. If to go from a leg to the hypotenuse, I multiply by square root of 2. Then to go backwards, I divide by the square root of 2, right? Well, what happens if I divide by square root of 2? Can't have it on the bottom. 10 root 2 over 2, which you're right, is 5 times the square root of 2. That would be both the legs because they have to be the same. And this has to be 45 also. Yes, no, maybe so? My phone is ringing. I know y'all hear that. Not ringing out, it's vibrating. Well, I don't hear it now, but. All right. Let me show you 30, 60, 90, because it's the harder of the two, and then we'll put everything together and do some examples. Right, Armando? All right. Now, you learned something in, remember these are all right triangles, but you learned something in geometry called the hinge theorem. Put your hands together like this. Pretend like this is the angle of a triangle and there's a string that is connecting your two middle fingers. Don't stick them up or anything here. Just imagine a string connecting them. As you make this angle bigger, what happens to your piece of string? Gets longer, it stretches out, right? And as my hands come closer together and my hinge closes in, what happens to that side? It's smaller. That's what we call the hinge theorem. Do y'all remember learning that in geometry? Okay, the hinge theorem says that the bigger the angle gets, the longer the leg across from it. Okay, so remember that because that's going to help you. This will help you as you try to determine long leg and short leg here. Because if I've got a 30, 60, 90 triangle, that means one of the angles is 30 degrees and the other one is 60. The shorter leg goes across from the smaller angle. The bigger the angle, the longer the leg, right? So I've got three different angles here, right? I've got 90, 60, and 30. 90 is the biggest, so that should be the very longest. You can, but you can't always look and tell. Like sometimes you'll have to, it might just be ever so slightly off. But there's a reason you have to, I'm fixing to show you. All right. For 30, 60, 90, everything is based on the short leg. And that is the leg across from the 30-degree angle. Okay? You have to be able to identify that leg. Yeah. Yes, that's exactly right. The shortest leg is across from the smallest angle. So this is my short leg. Okay? Everything works from the short leg. If you don't start with the short leg, you have to get to the short leg. Okay? And I'll show you exactly what I'm talking about. So the short leg, I'm going to call that X. I'm going to give it a variable. Okay? Now, from the short leg, you take that value and you multiply it by the square root of 3 to get the long leg. So X times the square root of 3 gives me the long leg. Again, back to the short leg. If I double that short leg, I get the hypotenuse. Okay? If you start with the short leg, it's really easy. But if you start with something else, it gets a little bit harder. So let me show you what happens. I'm going to show you one of each scenario, okay? Okay, Miss Minky. Because you'll have them on your homework going every different direction. I want to make sure I give you some examples here. Find all the missing sides and angles. Oh. All right, we know the other angle. That's a gimme, right? That's 30. So I recognize this being a special right triangle because if it's 45, 45, 90 or 30, 60, 90, it's special. Not the kind you're, what? 2 is the short leg. How do you know that 2 is the short leg? It's across from 30. So I'm good to use that number to base everything else on, right? So to get to the long leg, which is across from 60, what do I do? 2 square root of 3. And now what's the hypotenuse? Okay. 4. Right. Right. Until you don't. Let's start with the hypotenuse this time. Let's do it. Y'all. Harris. All right, Harris, what's my missing angle? 60. How do you know? It's a 30, 60, 90. Which side is my short leg? Go to 30 and look directly across. That's my short leg. Do I have that given? No, but I have the hypotenuse. I have to make my way back to the short leg in order to find everything else. So it's half of the hypotenuse, so it's 6. And now how do I find the long leg from that? 6 square root of 3. Yep, always the opposite of 30. Let's make it harder. Harris said this is too easy. Yes, yes. So you saw that. All right, look at what I have and look at what I have. Harris, get yourself together. All right. The missing angle is what, Harris? What? I need to make my way back to what? The short leg. So I need to make my way back here. What did I start with? What did I start with? What have I started with? The long leg. How do I get from long leg to short leg? Divide by, not square root 2, square root 3. So this Yep. 7 divided by square root of 3. I can't leave it like that, though. Square root of 3, square root of 3. So I got 7 square root of 3 over 3. Short leg to long leg multiplies by square root of 3. So to go backwards, I divide by square root of 3. Now, how do I get hypotenuse? Multiply what by 2? Short leg, always the short leg. What is this times 2? 14 square root of 3 over 3. Short leg times 2 gives you the hypotenuse. Yep, it's because if I multiply by 2, that's 2 over 1. You just multiply the numbers in front there. All right, guys. I know this looks easy right now, but it looks easy because I know how to do it. I promise you this is tough. All right, let me show you what your work's going to look like too. No. Find everything. Yep. Both of them. Oh. This is those kind of SAT questions you see a lot. If you've taken SAT or ACT recently, these are the kind of questions they will throw on there all the time. So it's a good thing for you to practice now anyway. Oh my God. Well, don't now because I'm showing you how to do them. Yeah, I'm not going when do we get our SAT stuff? We should do like towards the end of the year. We should do some like SAT. Okay, can we just figure out this problem? Like I'm literally just asking questions. This is SAT prep. This is. Yeah, but I'm saying like a lesson like I'm all like how to. This the bottom one what? They share. Yes. Yes, so the long leg of the top one is the hypotenuse of the bottom one. If you need to, do that. If you need to separate out the triangle so you see it, because this is the hypotenuse of the 45, 45, 90, but it's also the long leg of the 30, 60, 90. I start with the 45, 45, 90 because I know that these sides are going to be the same. Which means that the hypotenuse takes that side length and does what? Root 2. It gets really confusing because you always want to double it, but it only doubles in the 30, 60, 90. And the 45, 45, 90, it multiplies by square root of 2. So if I have 6 times the square root of 2 times the square root of 2, what do I get? 6 times 2, which is 12. What you got, Luke? Yes. Because the legs are going to be the same since it's a 45, 45, 90. How do you find what? You got to make it back to the short leg first. Then you double for the long leg. I mean, for the hypotenuse. If it's what? That stays there. That doesn't happen. All right, so now, this is 30. I need to make my way back to the short leg. What do I have? I have the long leg, right? How do I get from long leg to short leg? divide it by the square root of 3. If I divide by the square root of 3, watch what happens. I get 12 root 3 over 3. What's 12 divided by 3? 4 times the square root of 3. This side is 4 square root of 3. Then I double that. Good. 17? 17 or 16? Which one? 16 or 17?
You choose one. One. No. She said one will be back.
17. Hot July moon. How's it go, Harris? Sing it.
No, don't let her in, Mia.
Yeah, he did.
All right.
I didn't say that.
What? I didn't say anything. No, I'm not.
All right, go. Go. Mark, set, go. 17. Oh, y'all picked an easy one.
Oh, this is a hard one then.
I already don't even know what to do.
Don't say it.
Oh, yeah, Malaya does, by the way. What? He did like twice.
Whoa.
That's 20 a month.
Not like it's right.
How do you get from leg to hypotenuse on a 45, 45, 90? Times square root of 2. All right, so what do I have in my 30, 60, 90? Do I have short or do I have long or do I have hypotenuse? I have short. That's a good thing, right? Everything's based off of short. So from short leg to long leg, I multiply by. So if I got 6 square root of 2 times the square root of 3, that is 6 root 6. That's if I had the long leg first. Look at what I got. I got the short leg. I know it's frustrating because you have to. That's why I said always look at that 30 and look directly across. If I don't have it, how am I going to get there? Okay. Take that short leg again, and how do I get to the hypotenuse? Double it. What is it? 12 root 2.
Never retake
We retake them every year, but they don't print us new ones. Don't double what's under the radical, just double what's outside the radical.